In this lecture, we'll discuss theta notation. So in theta notation, it is asymptotic notation to denote equality or a same rate. Or we could also say that it is represent average bound or maybe exact bound, we can say, of a running algorithm in running time. So by using theta notation, we can calculate average amount of time needed for a code. So it called average case time complexity of an algorithm. So now we have to choose g of n such a way that in g of n, if you multiply two constant to g of n, so c1 into g of n is one function we will be getting, or one expression, and c2 into g of n another expression we will be getting. So f of n always ranges between c1 into g of n and c2 into g of n. So c1 into g of n is always less than or equal to f of n, and c2 into g of n is always greater than or equal to g of, like c2 into g of n is always greater than or equal to f of n. So where c is a constant and n is a function. So c, instead of c we can say c1, c2 are the constant and n is the x-axis notation through which it will go. So average bound. So it is also called as average bound. Now theta notation. So you can see here till n0, till this point even f of n is faster than c1 g of n and c2 g of n, but after in between this point it's like f of n is between c1, f of n is greater than c1 g of n and it is less than c2 g of n. And after this point, like between these 2 points, f of n is less than both c1 into g of n and c2 into g of n. But now after this point you can see that f of n is continuously going and staying between c1 g of n and c2 g of n. So it is like average between, or it is kind of just confined between c1 g of n and c2 g of n. Or we can also say that this is like big O, f of n equal to big O of c2 g of n, and f of n is again big omega of c1 g of n. Okay, so this is another way of representing it. But in this case, like if you have both big O and omega notations, then we can directly say that f of n is a theta bound or theta notation, theta bound with respect to theta of g of n. Okay, so this is our f of n. So let's go to next slide. Let's take this example where now we have again f of n equal to 3n plus 2 and g of n equal to n. So let's plot first. So f of n is 3n plus 2, so I will just take a line with some slope, and this slope is our f of n. Now I will change the ink color so that we will just see the difference. So now let's take c1 equal to 1 and c2 equal to 4. Okay, I will be taking c1 equal to 1 and c2 equal to 4, and let g of n is n. So now we will just make n, we will make again our table n, f of n which is equal to 3n plus 2, then c1 into g of n is equal to n, and c2 into g of n is equal to 4 into n. Okay, so let's calculate these values now. So n equal to 0, 1, 2, 3, 4, 5, 6, 7. So we'll take some values little bit more so that we'll get some difference. So for n equal to 0, what is f of n? F of n is 2. But in both the cases here n is 0, for n is also 0. When I go n equal to 1, I will be getting f of n equal to 5 and c of n equal to 1. c1 g of n is like n is as it is 1, and this c2 g of n will be 4n, so I will write 4 here. Now if n is equal to 2, I will be getting 3 into 2, that is 6 plus 2, that is 7, this will be 2 as it is, and this is 4n means 8. Again here I will be getting n equal to 3 means 9 plus 2 11. I will be getting 3 here, and that is 4 into 3 12. So now again you can see that for 4 this is 3 into 4, that is 12 plus 2 14, and n is 4 as it is, and here it is 4 into 4 16. So for 5 it is 15 plus 2, that is 17, 5 and 20. Then again for 6 it is 18 plus 2 20, then this is 6, and 4 into 6, that is 24. Then again 21 plus 2 23, then this is 7, and this is 28. So you can see that a line with n will be staying something like this, and the line with 4n will have little bit slope, will not be exactly same of this line. Slope should be, let me just erase it, because you may get feeling that the slope is same. Okay. So now for n we will be getting something like this, and for 4n you can see that after, like you can see c1 into g of n is always less than this line. Like we are just taking n greater than 0 and we are checking, but c2 into g of n will be after, for n equal to 1 it is lesser. So I will just say that this is n equal to 1 and this is n equal to 2. So after n equal to 2, if you just see, for n equal to 2 it is already higher than that. So our intersection point may be somewhere before 2, before n equal to 2. So your slope will be something like this. So now you can see that this is our c1 into g of n, which is equal to n. What is f of n? 3n plus 2. And this is c2 into g of n, which is equal to 4n. And now we can see that after n equal to some value, like which is between, ranging between 1 and 2, f of n is less than 4n and it is greater than n. So f of n is staying between these two values, c1 into g of n and c2 into g of n. So this is our theta notation.